Good morning, dear students. I'm Mrs. Rania. Today we will continue our lesson 1, Motion in One Direction. Today we will talk about types of speed. To know types of speed, let's see this picture. In this picture, we have a car. The car covers the first 100 meters in 10 seconds, then 100 meters in 10 seconds, and the last 100 meters in 10 seconds. From this picture, we can conclude that the car covers equal distance in equal period of time. The first 100 meters in 10 seconds, the next 100 meters in 10 seconds, the third 100 meters in 10 seconds. So it covers equal distance at equal period of time. This is called regular or uniform speed. Uniform speed or regular speed, it's the speed which the object moves when it covers equal distance at equal period of time. On the other hand, when the car moves 100 meters in 10 seconds and then 120 meters in 10 seconds and 80 meters in 10 seconds, what do you observe? Yes, the car covers unequal distance at equal period of time. This is called irregular or non-uniform speed. It's the speed that the body covers equal distance at unequal period of time or unequal distance at equal period of time. So we have two types of speed, regular and irregular, uniform and non-uniform. Regular or uniform, the body covers equal distance at equal period of time. While irregular or non-uniform speed, it covers equal distance at unequal period of time or unequal distance at equal period of time. Let's solve what's meant by question. The object moves at a regular speed of 50 km. We have to concentrate regular speed. What does it mean? Yes, it means the body covers equal distance at equal period of time. And we will write the distance equal what? 50 meters. So this means that the object moves or covers a distance of 50 km in each 1 hour. Each word it refers to, this is a regular speed. In each 1 hour it covers 50 km. This means the body or the car moves with a regular speed. Let's solve a problem. From the following figure, does the person move at a regular speed or at an irregular speed, and why? To know the regular speed or irregular speed, we have to get first the speed in each period. Okay? So, let's see the figure. The body or the person covered the first 1 meters in 1 second. From 1 meter to 3 meters, it covers, yes, 2 meters. From 1 meter to 3 meters, it covers 2 meters. The second 2 meters here covered in 2 seconds. From 3 meter to 4 meter, it means 1 meters in 1 second. From 4 meter to 7 meters, it covers, yes, 3 meters at 3 seconds. So we have to get first the speed at each distance and then we will see is it regular or irregular. V1, the first speed, it covers 1 meter in 1 second. To the speed, distance over time, 1 meter per second. Don't forget, meter per second is the measuring unit of speed. The next, V2 equal D2 over T2. Yes, it covers from 1 meter to 3 meters. So 3 minus 1 over 2, it covers 2 meters in 2 seconds. The result will be 1 meter per second. The third speed, distance 4 minus 3, it covers, yes, from 3 meters to 4 meters. So it covers 1 meter in 1 second. Okay, so the result will be 1 meter per second. Fourth speed, 7 minus 4 over 3 equal 1 meter per second. What do you observe? V1 equal 1 meter per second. V2 equal 1 meter per second. V3 equal 1 meter per second. Also V4 equal 1 meter per second. So, is it regular or irregular speed? The body covers equal distance at equal period of time. So this means the speed are equal. So the person move with a regular speed or uniform speed. Why? Don't forget why. We have to answer why. Because it covers equal distance at equal period of time. Now, average speed. What's meant by average speed? Average speed, it means the total distance that the body covered divided the total time. Okay? Average speed at the speed, distance over time. While here we said total distance. So, average speed equals total covered distance over total period of time. Okay? So, what's meant by average speed? Yes, it's the total distance covered by the moving body divided the total time. Let's solve a problem, or what's meant by question. What's meant by the average speed of a moving car is 40 km per hour. As we said before, we have to say the definition of the average speed and write the number that we have. Okay, what's meant by average speed? It's the total distance covered divide the total time. We will start our answer with this means that total covered distance 40 km by the car through a total period of time in 1 hour. Okay, we have distance here 40 km and the time 1 hour. Okay, let's solve the problem. This problem, an application on an average speed. Calculate the average speed of an object that cover a distance 84 meters through 10 seconds, okay? And then 56 meters through 8 seconds and 28 meters in 4 seconds. What is the rule for the average speed? Average speed equal total distance divided total time. We have 3 distances. D1, 2, 3. Distance number 1, 84. Distance number 2, 56. Distance number 3, 28. Divided over the total time. Time 1, 2, 3. Number 1, 12, 8, and 4. And that's it. The result will be 7 meters per second. Don't forget, please, the measuring unit. Speed as average speed as a speed, its measuring unit is meter per second. Relative speed. Relative speed, it's the speed of an object relative to another observer. Measuring relative speed depends on the position of the observer, like here in the picture. The observer is at rest. He observes the speed of each car. The red car, its speed is 100, and the yellow car, its speed is 80. So the red car, the relative speed of red car relative to the observer, which is at rest, is 100. And the relative speed of yellow car relative to the observer, who is standing on the ground, is 80. So measuring the relative speed depends on the position of the observer. Let's see the cases of the observer. When the observer is at rest, the relative speed of the object equals its real speed. For example, here in the picture, the speed of the car is 100 km per hour, and the observer there at rest. He doesn't move. So the relative speed of the blue car equals its real speed, which is 100 km. So when the relative speed equals its real speed, when the observer is at rest. Let's see if the observer is moving. When the observer is moving in the opposite direction to the object, what happens? The relative speed equal the real speed of the object plus the observer speed. Let's see, for example, the yellow car, its speed is 60 km per hour, and the observer in the yellow car. So the observer in a state of rest or in a moving state? Yes, the observer is moving in the yellow car. And the object speed is the blue car, which is 100 km. We have three terms: relative speed that I want to calculate it, object speed, and observer speed. Concentrate. The observer speed here is 60 kilometers. The object speed here is 100 kilometers. Here, the object and the observer are in the opposite direction. So, the relative speed of the blue car relative to the observer in the yellow car equal the object speed plus the observer speed. So students, when the observer is moving in the opposite direction of the object, the relative speed equal the object speed plus the observer speed. Here, the object speed is 100 and the observer speed is 60 kilometers. So, they are in the opposite direction. So, relative speed of blue car relative to the observer in the yellow car equal 100 plus 60 equal 160 kilometers per hour. So, relative speed here is more than the real speed. When the relative speed more than the real speed? Yes, when the observer in the opposite direction of the object. Next, when the observer is moving in the same direction but at a different speed. Here, relative speed equal the object speed minus the observer speed. Let's see. We have two cars. Blue car 100 and yellow car 60 kilometers. Where is the observer? The observer in the yellow car. So, the observer at the same direction of the object. The relative speed of the blue car relative to the observer in the yellow car, when they are in the same direction but different speed, equal the object speed minus the observer speed as they are at the same direction. So, the relative speed of the car equal 100 minus 60 equal 40 kilometers. Here, relative speed less than the real speed of the object. Why? The real speed of the object equals what? Yes, 100. This is the object and this is the observer. The speed of the object is 100 and the speed of the observer is 60. Relative speed of the blue car relative to the observer in yellow car when they are in the same direction equals the object speed minus the observer speed. Its real speed equal 100. Its relative speed relative to the observer in the yellow car equal what? 40. So the relative speed is less than the real speed when they are in the same direction at different speed. Okay, let's see. When the observer is moving in the same direction with the same speed, what do you think? When they are in the same direction, relative speed equal the difference between them, the object speed minus the observer speed. It equals what? 0. Let's see the picture. When they are at the same direction, where is the object? The object is the blue car. Where is the observer? In the yellow car. So the speed of the object 60. The speed of the observer 60 kilometers. They are at the same speed in the same direction. So it seems static. It seems the blue car seems at rest. Why? Because they are at in the same direction at the same speed. So the relative speed equals 60 minus 60 equal 0. Okay, here The object, let's revise. The relative speed of the object when the observer is at rest equal its real speed. When the observer is moving in the opposite direction, the relative speed equal object speed plus the observer speed. When they are in the same direction, the relative speed equal what? Yes, the object speed minus the observer speed. Let's solve our what's meant by question. It's a very important question. Relative speed of a moving car is 90 km. Here, as we said, in what's meant by question, we have to define the meaning of relative speed with numbers. Yes, relative speed, this means that. This is our first word to answer this question. The speed of the car relative to another observer equals 90. As we define the relative speed and we put numbers, okay? While here, the relative speed of a moving object equal its real speed. When the relative speed equal its real speed, yes, this means the observer is at rest. The relative speed of a moving car equals 70 km per hour to an observer moves in the opposite direction at speed 20 km. What does it mean? This means that the real speed of the car equal 50. We solve it as a problem. 70 minus 2. Okay? Thank you, dear students, and see you again.